Hello, this is Mr. Wynn, and this side lesson is about quadratic systems. So a system, remember, is two or more equations. In a quadratic system, at least one of the equations is quadratic. And for our class, we'll have two cases. We either have one quadratic equation and one linear, so one U shape and one line. And we're trying to figure out where they cross and how many times. This first one crosses twice, or intersects twice, right here and right here. So that's two solutions. The second one crosses only once, so one solution. And this last one doesn't cross at all, so no solutions. So that's old, same thing. Or maybe we have two quadratic equations. We have two u's, but it's the same idea. They cross or intersect twice. So again, two solutions. They might cross just once, so one solution. Or they cross no times, no solutions. All right, but our job is to find out if they cross, and if they do, where. And a solution, remember, is where they're both the same, they're equal. So basically we have to set the equations equal to each other and solve. So here are the steps. Set the two equations equal to each other. You might have to get each equation equal to y, so get y by itself for f of x or 0, then do substitution. Step 2 would be solve using quadratic formula to find the x's. You may also sometimes factor or use completing the square, but I will do quadratic formula. And last, once you have your x's, plug in to get the y's. Remember, the answer is the point, the x comma y coordinate. So here's the first example. Find where y equals 2x squared plus x minus 7 intersects y equals 2x plus 3. Well, notice they both say y equals. So I'm going to replace this y on the left with this y on the right. So that is 2x plus 3 equals 2x squared plus x minus 7. Now I do quadratic formula, but I'm not ready. I need standard form. I need a 0 on the side. So I'm going to keep a positive, the thing next to x squared. So I'm going to move everything on the left to the right side. So subtract 2x first. I have 3 equals 2x squared minus 1x minus 7. Still not 0 yet, so I'm going to subtract 3. So 0 equals 2x squared minus x minus 10. Now I can do quadratic formula. So we know a equals 2, b equals negative 1, c equals negative 10. So in the formula, it is negative b. So change sign to b, so positive 1 plus or minus square root of b squared in parentheses minus 4 times a times c all over 2 times a. Do the discriminant first. So what is that? 1, 8, 80, 81. So we have 1 plus or minus the square root of positive 81 over 4. Well, the nice thing is square root of 81 is 9. All right. If it's a nice number like that, you have to do two cases. So I do 1 plus 9 over 4 and 1 minus 9 over 4. So that's 10 over 4. That's 5 over 2. In this case, I'll do 2.5. I'll do the decimal. That's negative 8 over 4, which gives us negative 2. Those are my x's, but I need to find the y's. So I gotta plug it in. Now, it's your choice to plug into either one. I recommend plugging into the easier linear equation. So I'm basically use this one right here. So we know y equals 2, I'm plugging the first one, times 2.5 plus 3. Well, that is 5 plus 3, which equals 8. So my first point is, and I'll put up here, 2.5 comma 8. And I have a second point, so I gotta plug in the other one. So again, y equals 2 times negative 2 plus 3. So that's negative 4 plus 3. That gives me negative 1. So the other point is negative 2, negative 1. Those are my answers. So this crosses twice. I don't even need the picture. Now if you use the picture, I'll use the calculator to show y'all. So turn on y equals 2x squared plus x minus 7 and 2x plus 3. So I graph that. Notice they cross twice. The one on the bottom left is -2, -1. The one on the top right is 2.5, 8. The calculator could check this for you. If you press second trace, go calculate, go to 5, intersect. If you go close to intersection and press enter 3 times, so 1, 2, 3, it says -2, -1. That x is -2, y is -1. I'll try the other one. Second trace, 5 for intersect. Go to the other intersection, go close to it. Then press enter 3 times. 1, 2, 3. It says 2.5, 8. So the calculator can find you the number as well. Alright, here's the next one. Find where these intersect. Now instead of having y equals, it says f of x equals. But it's the same idea. I'm just going to replace this f of x with this other f of x. So I have -1 equals x squared plus 8x plus 15. I want to do quadratic formula, but it's not in standard form, so I'm going to move everything to one side. I'll add 1. So I have 0 equals x squared plus 8x plus 16. Now I can do quadratic formula. So a equals 1, b equals 8, c equals 16. The formula, plug it in, so that's -b plus or minus square root of b squared in parentheses minus 4 times a times c all over 2 times a. So let's see, 64 minus 64 is 0. -8 plus or minus square root of 0 over 2. Well, the square root of 0 is nice. That's just 0. Now do the two cases. Now if you add or subtract 0, it doesn't really matter. It's going to be the same case twice, but just in case y'all aren't sure. -2 over 2. That's -8 over 2 is -4. -8 over 2 is again -4. So with the same x, but remember we got to plug it in. Our answer is a point. So I go to the linear equation. There is no linear equation. Alright then, I will use the quadratic equation. So to find y, or f of x, we plug that in. So I'm going to do -4 squared plus 8 times the -4 plus 15. I just type in calculator just like that, but that is 16, 32 plus 15. That is -1. That's our y. So our final answer is -4, -1. This only crosses once. So if there are two intersections, you'll find both of them. They'll have two different x's. There's only one intersection. You only see one unique x. There'll be a repeat. So let me try this. X squared plus 8x plus 15. And the other one is -1. You will see that it crosses or touches the very bottom of the parabola. So second trace, 5 for intersection, go really close to it. Where is it? Right there. Enter, enter, enter. It says it's -4, -1, just like I got. Alright, and the last one, find where these two intersect. Well, again, replace f of x with f of x. So our equation is -x squared plus 3 equals x plus 6. And the order doesn't matter. You can reverse if you want. Get everything one side. I like a positive, so I'm going to move this over. Alright, a lot of people don't like a negative. So 3 equals positive x squared plus x plus 6. Subtract 3. So I have 0 equals x squared plus x plus 3. Do quadratic formula. So a equals 1, b equals 1, c equals 3. Alright, and fill out the formula. -b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Do the inside, the square root part first, the discriminant. So that is 1 minus 12 is -11 over 2. Now, we want to find where they intersect. We don't really care about imagining answers. This is imagining because this is negative. This, you can stop right here and say no solution. They do not cross because there's a negative number inside. There's two imaginary answers, but not real. And we could check using the calculator. So it was -x squared plus 3 equals x plus 6. If we look at this, there's my u, it's upside down, and there's a line right above it. They don't intersect at all. They'll never cross, so no solution. All right, try this practice problem. And there's the answer. If you can solve this, you should be good for the quiz in class. Again, this is Mr. Wynn. Thanks for watching. See you in class.